we created a project called Smart Personal Rapid Transit System by Quantum Locking and Superconductivity.
So first I'll explain the Personal Rapid Transit System. So that is, it's PRT for short, and that is a system where there's podcar-like vehicles that are levitating over our track, and these vehicles are basically individual cars that will allow for point-to-point transportation for the people that use it. And you just have to go to a local station, and then you basically request a car, and it'll take you directly to the place that you want it to go.
And this ties into the superconductivity and quantum locking part of our project, because these vehicles in the PRT that Scott explained are basically levitating over a track of electromagnets using these principles. Basically, it's a system very similar to how a ping pong ball can levitate over the hair dryer. The jet of air is pushing the ping pong ball. It's not going through the ping pong ball, so it's pushing it around it. And the same thing with the superconductivity, instead using magnetic field in the case of superconductivity.
Yep.
Okay, thank you. These are the materials that we will be using for our superconductivity demonstration. Right here, this is the actual superconductor that we will be using. This is a thin superconducting film of YBCO that is 2 orders of magnitude better than the bulk superconductors. More importantly, the fact that the superconductors are thin, this allows us to demonstrate quantum locking without the usually dominant effect of the midair effect, which is also called flux pinning.
And this right here is just the bulk superconductor, and this is just the pure YBCO. And next to that is the magnet that we are going to be demonstrating with this as well. And it's just a simple neodymium magnet. And here are the magnets for our project. These are the bar magnets, and this is the ring magnet. This will allow it to be locked on an axis while this will just allow it to move.
These are much more powerful than this magnet. This is actually the kit that we used previously, and it didn't really allow us to show what we had really intended in showing of how superconductivity will be used in our system. This was just a simple demonstration versus our kit that we have right now. This one, with these more powerful magnets, allows us to actually show the real materials that we will be using in the final product.
Yep.
In order to cool down the superconductor to its critical temperature, we will also be using liquid nitrogen, and we also have these 2 things that Saad will explain in more detail.
So these are basically the tweezers that will allow us to pick up these different objects, and these tweezers can be cooled to very low temperatures, and they will not break. So we are going to be using this to pick up our superconductors and our magnets and placing them to demonstrate the superconducting properties. Would you like to explain the Petri dish?
Yeah, this is a special Petri dish. It's designed specifically for cold temperatures such as liquid nitrogen, as well as tweezers. And this really is extra strong glass, and it helps so that in the case that when it does get cold, it will not break and shatter as some other glasses will. Okay, thank you.
Yep.
That's enough, it's still there.
Thank you.
Yeah, I think it's good. That was good. Okay, lift it that way. A bit more that way.
External button.
Oh, right. It's all frozen. Now I think we can flip it over. Lift it a bit higher.
Yeah, we can even see it.
So you can see it's completely. Polar rotation. You can see it. Just let this here quickly. Oh, okay. I think this would be the right. Yeah.